Now, one of the other questions I get asked on a regular basis is, can helicopters fly backwards? Why can they fly backwards? And is there a limitation on that? So a helicopter can fly in all directions. You can fly forwards, side to side, backwards, up, down. And you can fly in diagonals, up, 45 degrees down, let's say, and up, and spin around and do all sorts of things. So it's a very versatile machine, a helicopter. So it can fly backwards. So you've got the disc on top of the helicopter, the main rotor spin around, it creates a disc, and if the pilot pulls aft, pulls backwards on the cyclic, the effect is that the disc tilts backwards, and then the rotor thrust and lift being produced on all the blades. The total rotor thrust is not pointing up, it's pointing backwards a little bit, and it pulls the helicopter backwards. So that's essentially the way it works. It pulls the helicopter backwards, right? So it can go backwards. But the helicopter is not designed to fly in all directions, side to side, up, down, forwards, backwards, at higher speed. It's only designed to fly at higher speed in one direction, and that one direction is forward speed, because that's how the aerodynamics of the fuselage has been designed, that the airflow comes over the nose of the helicopter, around the side of the helicopter, around the top of the fuselage, around the tail boom, across the stabilizers, horizontal wings, let's say winglets the helicopter might have, the vertical fin at the back, or vertical stabilizer that it has in the back, to give it some stability. So that's what we call, the profile of the helicopter, the design of the helicopter, to minimize what we call parasitic drag, or parasite drag, or fuselage drag, right? Any drag on the helicopter. So also, ideally you want the helicopter fuselage skin to be as clean as possible, right? So that you're minimizing the amount of turbulence created over that fuselage. Because if you've got more turbulence over the fuselage, if you've got a poorly designed fuselage, then what's going to happen is that the airflow over the fuselage won't be as streamlined. So you're going to demand more power to overcome the drag on the fuselage, more engine power and more rotor power, or more lift and thrust from the main rotor to overcome that drag. Okay, so in many ways, let's just say or many helicopters, for example, that forward speed is, you have to reduce the forward speed. Let's say if you take the doors off, or if you want to open the doors in flight. Some helicopters have very strict restrictions, say you have to dramatically reduce the speed before you open a door in flight. Let's say below 50 knots, 60 knots in the case of the helicopter I fly around, it's 60 knots. If you remove the doors, then instead of it being a 140 knot helicopter, 150 knot helicopter, it becomes a 110 knot helicopter, or 100 knot helicopter, or whatever it is. So it really depends on the helicopter design. Now, some other helicopters don't have any restriction at all. There may not be a restriction. So it's not all the case for every single helicopter. It really depends on the design and how it's been certified as well, how it's been tested and certified. So the whole point is that the helicopter is designed to fly forward. The airflow comes over the fuselage, and it becomes streamlined. It's most aerodynamic when it's going forward. It's not aerodynamic if it's flying sideways, or left or right, or up, vertically down. It's not aerodynamic in its best sense. And exactly the same if it's flying backwards. In terms of the engine power and the rotor thrust and lift, that's exactly the same in whichever direction it goes. But what you're going to have, let's say if you're flying backwards, well, the airflow, the wind, or the helicopter is moving into airflow that's coming from the rear. So it's pushing against all those aerodynamic surfaces. Therefore, there's going to be a limitation on the rearward speed of that helicopter, because it starts becoming a lot more unstable. You can fly backwards, up to a certain amount, but it won't be anywhere near as fast as going forward, because you're working against the horizontal stabilizers, you're working against vertical stabilizers, vertical fins. The fuselage itself is not aerodynamic, it's not shaped aerodynamically to go rearward. So So that's why it can fly backwards, but there's going to be a certain speed where it's not aerodynamic enough, or it becomes unstable as well. And this is why it's really key for a helicopter to be very careful if you've got a very strong tailwind, and also landing with a tailwind, especially a strong tailwind, of how effective the helicopter control will be. And then if, let's say, if an emergency were to happen, then you don't really want to be landing with especially a strong tailwind, but any kind of tailwind. And in certain cases, the way the helicopter has been certified, there are certain maneuvers that prohibit that maneuver being performed with any kind of tailwind as well, because of the aerodynamic effect of a wind or an airflow from the rear, and it's hitting the surfaces on the fuselage that they're not designed to come from that angle. They can come from to a certain degree, but not a great deal. Now, certain maneuvers, they're prohibited with any kind of tailwind, any kind of rearward wind, because in those maneuvers you need the maximum power margin possible to give you the best performance, the best power to weight ratio, that kind of thing, the best margin from rotor thrust and total rotor lift and total rotor thrust over all the drag components on the helicopter. So in that case, they're saying, well, you can't have any tailwind. That's going to increase the parasitic drag, the overall drag on the fuselage as well. That's why it's got to be coming from the front of the helicopter, or it's got to be coming from a left quartering or a right quartering wind. You've got to have headwind component. In some cases, some helicopters say there's a maximum crosswind component. You can't have something over 30, 40 knots, let's say. A tailwind you can't have over 25 knots, 20 knots, 30 knots. It depends on the design of the helicopter. So that's why. So helicopters can fly in all directions. They can definitely fly backwards. They just can't fly backwards at the same speed or anywhere near the same speed as in forward flight, because the fuselage isn't designed for high speeds in any other flight configuration other than forward flight at higher speeds, I should say. And then with that, there are rearward speed limits based upon that. And because the drag over the fuselage gets so much, the lifting surfaces are not designed for it. And everything like that. Now, when we're talking about flying high, the height, and flying fast, the fastest speed, and with flying any kind of rearward speed, then you're talking about the airflow over the blades as well. And at what point is the turbulence over the blades too much? So then we're talking about, in terms of height, we're talking about blade stalling, retreating blade stall, this kind of thing. You're talking about wingtip vortices or blade tip vortices, this kind of thing. So all these aerodynamic effects and events start occurring when you start reaching the limits of what a helicopter can do. If it's reaching a height, and what's the overall, let's say if you want to fly backwards, what the overall limit will be backwards. And let's just say if you're flying at really high altitude, you might not be able to fly really high speeds, because you have to increase the blade pitch a lot to generate as much lift as you possibly can. The engine power is going to be reduced to because they're not performing as well at higher altitudes. So your blades are really high pitch. You're eking out as much lift as you can with the limited power that you've got. So to go forward speed, you're not going to be able to get higher and higher speeds. In fact, the airspeed, the maximum speed, the VNE, starts coming down with much higher altitudes, because the blades just can't give any more. The engine power just can't give any more. And also, if there is any kind of engine failure or any kind of problem there, then you're going to have to dramatically lower the collective lever, to reduce the pitch on the blades really, really quickly. Exactly the same with excessive forward speed. In terms of going forward speed, the retreating blade, the blade that comes down that moves away from the forward flight, that's what's called retreating blade stall, because you're getting more and more forward airflow that's coming over the retreating blade from the rear of the blade surface over the front, and it's causing more more turbulence, and therefore you get this retreating blade situation as well. So if you consider this as a rearward speed, if you're flying backwards, a really high speed, then what's happening is you're creating a lot of turbulence from the fuselage. That's also going up onto the rotor as well. The advancing blade that moves to the front of the helicopter, that's being hit by increasing turbulence from the rear as well, especially if it's a really strong wind and you're moving really backwards. So that's going to affect that blade as well. So there's lots of aerodynamic events and effects on the rotor, and also on the engine as well, to deliver the power to overcome the drag that's being induced onto the helicopter as well. In terms of flying backwards, there's a limitation on the fuselage, there's a limitation on engine performance to a certain degree, depends on altitude, but also on blade performance as well. So that's why there are reverse speed limits or rearward speed limits on a helicopter.